Hi everyone. Before we end today's class, actually, we have one more Python demo that I wish to share. Um, in the previous class, we had our first Python and the Anaconda uses for a visualization of the CO2 related statistics. And for that, we start to use the pandas, which is the one of the key and crucial Python packages. And using the pandas, we were able to load up the high volume of the data frame into the Python. And from there, we can also plot the several different plot, including line plot, bar plot, or pie plot, and lastly, a scatter plot. And by using the scatter plot, we were able to visualize the relationship between the energy consumption and the CO2 emission. And I found that if we use 20 more percent of our effort to understand the Python demo, actually we can also visualize the CO2 related statistics in a world map in a geospatial way. So I think this is really cool and interesting, and that's how I made up this our second Python demo that I'm sharing here right now, so that you can use it in a future application. So first of all, please go to iClass and open our lecture. And the current week, you may also find this Python demo for CO2 world map folder. And if you open it, you will have these two files. Please download it. And on top of this, we still need to use the previous data file. So please download this CO2 related statistics file as well. I will open I will create the one working directory here. So I will just say that this is for the Python demo, and just copy and paste every three files here. So first of all, if you open the file that has the extension of the SVG, you will have this figure, which world map and colored by the intensity of the color indicate the amount of CO2 that is emitted in each country. And more importantly, this figure is interactive, which means if you if you scroll your cursor on top of some country, for example, in the US, it's emitting about 5,000 megaton of the CO2 yearly, and in the Mexico, it's a 407 megaton. In South Korea, it's about 616 megaton, and then so on. And we only colored it by the 20 most CO2 emitting country. But if you want, you can color it even more with a country, so that we can have our information about the CO2 emission. And that's how I think it's very interesting to visualize it. And to visualize this, believe me, it only take 20 more percent of what we've done in the last class. So we are gonna make this one right away. So let me close it. And please open this Jupyter Notebook script. And so following the last class, you may know how to change your directory so that you can open your Jupyter Notebook in this specific location. So I will type the Jupyter Notebook, and this is how we can pop up your browser with a Jupyter Notebook. And now this is ready to go. So in the folder, please open this Jupyter Notebook script, and this is what you will have. My computer at the moment is converting our lecture recording into the MP4. So, and my laptop it's about at its full capacity. So probably that's why it takes more, maybe it takes a little bit longer than your computer, but I think this is okay for now. So this is what we want to have. We just see. And to do this, we need to have another packages that is called PyGar. And if you click this link, then it has explanation is what the PyGar is. And essentially this PyGar is to create these interactive figures like this. So if you move your mouse cursor on top of the figure, then you can see the numbers right away. And this is more interactive. So that's what this for. And And one of the sub function of the PyGar is actually visualizing the world map that is still interactive. So first of all, you have to import the pandas that we used the last time and also PyGar. But if you haven't learned this PyGar before, then you may encounter the error, and that's because you haven't installed PyGar yet. So open the Anaconda, and open the terminal, and from here, you should run this command. So if you go back to the folder here, it says to run this, you need to run the following command from the terminal. So you need to run pip install. So pip install is a command to install any open source Python packages that is online. And on top of this PyGar, you also need to download the second package. This is for visualizing the world map. And yeah, we are going to follow it. So you don't have to change your directory because this is in the environment where we are at, which is called base environment. From here, I will just follow what we have on the left. Install PyGar. In my computer, it's already installed, so it will be ignored. But in your computer, if you haven't installed it before, then it will have a process to download the required packages. And please follow the second line of the command as well, and then hit the enter so that you can also install your world map in it. And let's go back to the Jupyter Notebook. So after you install these two packages on the terminal, now you are ready to import two packages in your current Python. So now we have a number here without any message. That means it's successfully run. Now we have these two. And this is what we've done the last time. We import the CSV file. Please note that you should have your CSV file in your working directory where we just opened this Jupyter Notebook. So, and then we screen it by some small number of the column. Instead of using entire column, we only look at the country, years, population, CO2, and so on. And the last time we only had 9 countries, including the France. So 8 most CO2 emitting country plus France. But this time we are gonna have 20 countries where they are emitting the most CO2 in 2020. So it's in the first lecture note. And as one slight side note, I found that this PyGar and our data frame, they are using the different name for the country. For example, South Korea is actually called Korea, Republic of, and Iran is called Iran, Islamic Republic of, and Vietnam, we need to put a space between. So we tweak the name so that it can be compatible with a PyGar. So please run the second cell. And this is the table. So this part is basically screening only for the 2021 year and sorting value based on the CO2 emission, and then ascending first. That means we will have the country that emitting the most CO2 first, and then the less the later. So so China comes first, United States, India, and so on. And right now, China is the biggest, emitting the most CO2 among the country. But if you go back to maybe 2005, I assume the United States, yeah, of course, they emit more CO2 emission. And as the Chinese economics developed in after I think 2008, after the Beijing Olympics, then China significantly increased the amount of emission. That's how we now have more emissions from China. So yeah, we can change the year, and you can see the country name, and also you can sort it by other parameters such as CO2 per capita. So let's look at the CO2 per capita in 2021. So in 2021, surprisingly, the Saudi Arabia and the Australia is emitting more CO2 per capita than United States and then Canada, and that's because Saudi Arabia, it's one of the key oil production country, and that's why it may involve more CO2 emission, and Australia comes next, and the United States and Canada, they still have a lot of the CO2 emission. Actually, it's the Canada, not the China. So sorry. So United States and the Canada and the Russia, South Korea comes in fifths, and that's because South Korea, we still have a lot of the heavy industry and then iron manufacturing company. So then that's how we have very high CO2 emission per capita. And that's it. If you go to next, so we have one more cell. We actually have four more cells to go. This is pie chart from the last class. So screen by the year, and then sorted by the CO2 emission, and that's first part. And that's how we get the state DF underscore year. And by the way, DF stands for data frame. And that data frame dot plot is plotting and the what kind. We want to have a pie plot, and then categorized by the country, and then the proportion is measured by the CO2, and we want to have the number, then it's a proportion, and that's how we can add this input, and the label is done by the country name, and we don't need a legend, we don't need a white label, and the figure size is 10 by 10. We didn't have it, but I found that as we have now more countries, we need to have a bigger plot than before, so that's how we have it, and the title, and hit the enter, and that's how we get this pie chart. If you want to look at the 2005, then US comes first, and the US emit slightly more CO2 than the China, and 28% come from the US, 27 from the China, and South Korea is about 2%. I think South Korea is still emitting about 2% of the CO2 among these 20 countries. So South Korea, it's 2%, right? And this is the end of our previous demo. And from here, we are going to use the PyGar. So first, we specify the year that we wish to visualize it. And at the same time, we call this word map from the PyGar. PyGar.maps.word word and the round. And the second word starts with a capital letter, and the first word starts with a lowercase. And we can define the title for this word map. And also, we will have this key, and if we print out this key, it's simply a dictionary where we have a country name and their short name, country name, short name, and so on. So let's see. If I think we have South Korea here, and it goes like KR, and Korea. Korea Republic of. So that's a name for South Korea, and then the short name for the South Korea is KR, right? What about Japan? JP, and so on. So anyway, this show entire country name with their short name, and we are going to use that short name for this CO2 visualization. And this is inherited into the PyGar word map. So yeah, you can skip. I mean, you can reuse this part as much as you want. And this is part where we save the country name with the CO2 emission. So from the dictionary that we just created, we will ask what the short name is, and then after colon, we will provide the CO2 emission, and this row is repeated or iterated from the year data frame that we had, and that's it. So, and if you run, now we have a short name for Australia, and now we have an amount of CO2 emission that come from, and Brazil, Canada, China, France, India, Mexico, South Korea, and so on. So this is what we got, and to include that information into the word map, use this word map dot add, and then this is name of the variable CO2 emission, and then in the second input, I'll just provide what we just created. country name with their CO2 emission. And we're going to save that file into the new name. I will just name, this is about 2021, but 2021 new for demo. Run it and go back to the folder. This is what we had in from the iClass, but this is newly generated. And if you open, then you can see what we've seen in the very beginning of this demo. So that this is what we have. Let me change a little bit of the input parameter. So let's say we want to visualize maybe 2009 and the CO instead of CO2 emission, let's say we want to provide the CO2 per capita, CO2 emission per capita. So this is what we have. So from instead of the CO2, let's say we want to color it by the CO2 per capita, then you can change it. And I will just change the name. It's a 2005. And you can name it as you want, capita. And you will have the new figure. And this is per capita. So now Canada and the United States, and the unit, I believe it's a ton per person. So how many CO2 per, how many tons of the CO2 emitted from each person in the country. Saudi Arabia, it's very high. South Korea, it's intermediate, but much higher than Japan, I guess. And China, it's actually half of the South Korea it's a 2009, so it's 2009. And the Australia, it's emitting a lot per person, and South Africa, Brazil, United Kingdom, and then France, and that's it. And Russia is about 10 ton per person. Okay, this is our prepared for this world map visualization demo. And I just demoed with a CO2 emission, but if you have any presentation that is related to the world map, please use this demo to implement, because this is very useful, and it didn't take much effort, to be honest. We still use the same data frame come from the last time, but if you have any better interesting data, maybe more than the CO2 emission, then you can use that too. So, okay, and I will stop here. And thank you for listening.